The tropical sun blazed overhead on October 26, 1943. The time was 1400 hours. Beneath the rolling waters of the Bismarck Sea, death was about to arrive from above. Through dense cloud formations that hung like gray curtains across the Pacific sky, a single aircraft emerged. The crew had christened this machine Ghost. Its engines hummed with mechanical precision. The weapon it carried would reshape everything about naval warfare in these contested waters. American airmen had given this particular bomber a nickname that struck fear into enemy hearts. They called it Iron 8. The name came from its devastating collection of forward-mounted guns. 8 barrels pointed straight ahead like accusing fingers. The Imperial Japanese Navy understood they were losing ground in this grinding war of attrition. Ships disappeared beneath the waves daily. Supplies dwindled. Resources grew scarce. Yet their military minds had created one defensive strategy that seemed absolutely unbreakable. They called it the Armored Convoy Shield. These supply convoys represented Japan's lifeline to the resource-rich southern territories. Oil flowed through these shipping lanes. Bauxite moved in the cargo holds. Rubber filled the storage compartments. Without these materials, the war machine would grind to a halt. The Allied strategy focused on island-hopping campaigns across the Pacific. Each new invasion brought them closer to the Japanese mainland. But this strategy meant nothing if enemy supplies continued flowing, uninterrupted, to defend each successive island fortress. For months, Allied air forces had launched attack after attack against these vital convoys. They used traditional bombing methods from high altitudes. The bombs fell wide of their targets. Accuracy remained frustratingly poor. They tried low-level torpedo runs that brought aircraft dangerously close to enemy guns. These attacks proved catastrophic for the attacking pilots. Planes fell from the sky in flames. Crews died in the cold Pacific waters. The Japanese Navy had transformed their defensive capabilities after suffering crippling losses in the early island campaigns. Admiral Nishimura commanded the naval defense operations from his fortified bunker. This underground command center sat deep beneath layers of reinforced concrete in Rabaul. He had spent countless hours studying every Allied air assault since that terrible disaster at Midway. Battle reports covered his desk. Intelligence summaries filled thick folders. Analysis papers stacked high on metal shelves. From this careful study, he reached a revolutionary conclusion that contradicted decades of accepted naval doctrine. The Americans could not be stopped by relying solely on aircraft carrier duels. Traditional fleet actions were no longer sufficient. A new approach was needed. In the cramped confines of his subterranean command post, Nishimura drafted what would become Defense Order No. 7. The date was January 1st, 1943. The order contained words that would define Japanese naval strategy for the coming year. The directive was clear and uncompromising. Japanese forces would not retreat from convoy escort duties. They would allow enemy bombers to approach their formations. They would let the Americans come close. Then they would destroy the attackers from positions the enemy could not effectively reach. This was a complete reversal of previous defensive thinking. The mathematics of naval defense had shifted dramatically. In the early Pacific battles, attacking American torpedo planes had been eliminated within seconds. Concentrated anti-aircraft fire had cut them down before they could release their weapons. The exchange rate favored the defenders. A few ship kills came at the cost of enormous aerial losses. Now, Nishimura commanded a different kind of formation. Transport ships and cargo vessels sailed in tight formation. They were hidden within a protective screen of destroyers and heavy cruisers. This protection system had required extensive modification of every escort vessel in the fleet. Shipyard workers had labored for months installing additional weaponry. Every ship now carried a minimum of 24 anti-aircraft guns. These weapons were positioned for interlocking fields of fire. Coordination between gun crews had been practiced until it became instinctive. This dense concentration of defensive firepower created a lethal zone that extended outward from the convoy's perimeter. Allied pilots had given this defensive barrier a grim nickname. They called it the Shrapnel Dome. Building this impenetrable defense had consumed most of the Japanese Navy's available light artillery. Approximately 400 heavy guns had been redistributed from shore installations. Thousands of light machine guns were mounted on ship decks. The installation work had proceeded under extreme conditions. Deployment had stretched across months of continuous effort. Temperatures on the gun decks regularly reached unbearable levels. Toxic fumes from cordite powder filled the enclosed gun tubs. Ventilation was poor. Working conditions were hellish. The Japanese had created what military analysts would later consider the most sophisticated short-range anti-aircraft network of the entire war. 20 ships had essentially become a floating fortress covering 1 square mile of ocean. Their defensive calculations had accounted for every known American weapon system. They had prepared for low-level skip bombing techniques. They had planned responses to mast-height torpedo runs. They had considered high-altitude area saturation bombing. Their flak patterns had been designed accordingly. The Japanese planners had made one critical assumption. They believed the conventional maximum range of Allied fixed-forward guns was insufficient to engage them from outside their defensive envelope. This assumption would prove fatal. They had calculated responses to every Allied weapon except one. A modified medium bomber was approaching that could deliver devastating volumes of fire at distances they considered tactically impossible. The weapon that would shatter the shrapnel dome had been born from desperation in a machine shop thousands of miles away. Australian mechanics had worked around the clock on this project. The weapon that would fundamentally change the air war against convoys was not a new bomb design. It was not an advanced rocket system. It was the radical re-engineering of a common airframe. The Allied B-25 medium bomber would become something entirely different. This innovation had emerged from the disaster at the Battle of Palawan Strait months earlier. Torpedo bombers had been the standard tools for fleet engagement. Dive bombers had provided precision attacks on individual ships. Both weapon systems had been effectively neutralized by the sheer volume of Japanese flak. Traditional attack methods were failing. New solutions were desperately needed. The answer came through collaboration between the Southwest Pacific Air Command and a small team of aggressive specialists. These were ordinary mechanics and engineers working extraordinary hours. They were led by a maverick engineer whose official designation was Chief Warrant Officer Reese. Their mandate was simple yet revolutionary. They needed to develop a precision attack method that could neutralize the source of flak fire. The target was not the ship itself. The target was the guns that protected the ship. Official engineering records show that Reese's team began modifying B-25 airframes at an undisclosed base in northern Australia. The work started in February 1943. The technical designation was AFT modification. This stood for Anti-Flak Tactics Modification. The aircraft was being developed specifically for point defense suppression missions in the Pacific Theater. The technical specifications documented in Air Force records revealed the truly revolutionary nature of this modification. The standard bombardier's position was completely removed. The familiar glass nose disappeared. The co-pilot's forward controls were stripped out entirely. In their place, a solid metal cone was fitted. This housing contained an unprecedented battery of fixed guns. The nose had become a weapon. The original four-gun nose armament was quadrupled in firepower. The final configuration included 8 forward-firing machine guns. These were 50-caliber weapons, measuring 12.7 millimeters in diameter. 4 guns were clustered in the solid nose assembly. 4 more were mounted inside specially designed blisters. All 8 guns were synchronized to fire forward simultaneously. They were controlled directly by the pilot. The nose had effectively become the world's largest and fastest-moving machine gun turret. Initial tests over isolated ranges in June had demonstrated the synchronized gun's incredible capability. They could project a cylinder of solid lead and fire that maintained lethal density for extraordinary distances. This effective range was 3 times longer than Japanese anti-aircraft guns could reach. Test observers had discovered something remarkable about the high-velocity, armor-piercing incendiary rounds. These API rounds delivered a cyclic rate of fire that exceeded anything previously seen. They could penetrate flight armor plating, even at long range. The incendiary core was designed with a specific purpose. It would ignite high-explosive shells stored near gun tubs. These ready-use ammunition supplies were positioned along the ship's length for quick access. The aircraft flying at mast height was no longer a bomber. It was no longer a torpedo plane. It had become a heavy aerial gun platform. It was now a gunship. February 19th marked the first combat deployment of these revolutionary gunships. The crucial convoy route lay approximately 200 miles west of Rabaul. Standard attack tactics had been proving far too costly in terms of aircraft and crew losses. The new technique was elegant in its simplicity. Aircraft would fly low to avoid radar detection. They would fly fast to minimize exposure time. Most importantly, they would open fire from outside the flak envelope. The engagement on February 19th became the moment when the mathematical certainty of Japanese anti-aircraft defense simply dissolved. 5th Air Force records documented that the strike force approached the convoy at wave-top level. They maintained a wide, dispersed formation to avoid concentrated defensive fire. At precisely 0800 hours, something unprecedented occurred. The lead aircraft, Ghost, was still 800 yards away from the enemy formation. This distance placed it well outside the effective range of Japanese guns. At this moment, the pilot opened fire. Official after-action reports described the immediate effect with clinical precision. Streams of concentrated 50-caliber tracer fire maintained their lethal density across hundreds of yards. The bullets smashed into the target destroyer's forward deck structure with devastating impact. High-velocity API rounds shredded the thin-skinned gun tubs like paper. The incendiary components ignited ready-use ammunition stored nearby. Within seconds, the destroyer's main anti-aircraft battery was completely engulfed in smoke. Secondary explosions rippled along the ship's length. The entire port-side defense was effectively silenced. The Japanese had prepared detailed manuals for defending against various forms of air attack. These manuals had dedicated only a short section to medium bomber attacks. They assumed such aircraft would be maneuvering for bombing runs or torpedo attacks. During these maneuvers, the bombers would be vulnerable to sustained flak fire. Japanese planners had not anticipated an aircraft whose sole purpose was to act as a flying machine gun platform. They had not calculated for a weapon with lethal range extending 1,000 yards beyond their own defensive perimeter. The physics of destruction were both simple and devastating. The concentrated bullet stream delivered focused energy transfer that traditional armor simply could not handle. Immediate effects included multiple categories of destruction. Direct elimination of gunners and their weapons came from the sheer volume of impacting metal. Ignition and detonation of high explosive stores resulted from the API rounds, creating massive internal explosions. The suppression effect proved equally important. The terrifying sound of 8 heavy machine guns firing simultaneously created psychological impact. The visual effect of tracer streams converging on gun positions caused crew members to abandon their posts. Many dove for cover rather than maintain their positions. The Air Ordnance Group had perfected the API ammunition mixture through extensive testing. Documentation showed that rounds hitting at shallow angles would tumble and fragment inside ship superstructure. This maximized damage to control systems and gun directors. A single sustained burst lasting just seconds from one B-25 could render a destroyer's flak protection completely useless. The 5th Air Force after-action report was stark in its assessment. February 19th, 0800 hours saw anti-aircraft defenses completely silenced. Multiple cargo vessels were set ablaze. Friendly casualties included 1 aircraft with light damage. 0 crew members were wounded. Enemy casualties were estimated at 50 gunners and crew members killed. This represented a complete reversal of expected casualty ratios for convoy attacks. Previous engagements had seen heavy Allied losses with minimal enemy damage. Radio intercepts decoded by Allied Pacific Intelligence revealed Admiral Nishimura's frantic communications. These messages documented their complete unpreparedness for this new form of attack. The devastating success of the Iron 8 gunships was more than just a tactical victory. It represented a psychological catastrophe for Imperial Japanese Navy defense doctrine. The coordinated flak shield that had been the pride of Admiral Nishimura's strategy was now revealed as fatally flawed. Radio intercepts decoded by Allied intelligence units immediately following the February 19th attack documented complete panic in Japanese command structure. February 20th at 0800 hours brought urgent requests for immediate countermeasures against enemy 8-gun aircraft. Their range was deemed unacceptable by Japanese standards. February 20th, at 1430 hours, saw all units receive priority targeting orders. Fixed-nose heavy-caliber aircraft were now priority targets. Units were ordered not to engage within 2,000 meters of these weapons. February 21st at 600 hours brought authorization for evacuation of forward positions when fixed-gun aircraft approached. Gunners could not maintain their positions under concentrated fire. February 21st, at 1800 hours, saw escort commanders requesting permission for evasive maneuvers. They could not maintain course against concentrated long-range fire. Combat operations drove immediate battlefield modifications that were documented by Japanese Navy maintenance units. Initial problems included gunners refusing to remain at their posts under fire. Frantic yet futile attempts were made to weld thicker armor plating around anti-aircraft gun tubs. Solutions included mixing concrete with anti-aircraft shell casings to create temporary barriers. Smoke generators were deployed on ship bows in attempts to obscure hulls and reduce visibility for attacking gunships. These desperate measures proved completely ineffective. Within days, Allied intelligence documented what they termed systemic flak fatigue in Japanese crews. The psychological impact exceeded the physical destruction of equipment. For the first time in the air-sea war, significant numbers of Japanese gunners were abandoning their positions. This occurred before attack runs were even completed. They chose safety below deck, rather than confronting inevitable streams of concentrated fire. Post-war interrogations of captured Japanese sailors revealed the terror these weapons inspired throughout their ranks. Crew members described the noise of synchronized 8-gun fire as a continuous ripping sound. They called it the demon zipper or the dragon's rasp. Prisoners taken during subsequent operations were mostly survivors of sunken vessels. These represented the first significant naval surrenders of the entire campaign. Interrogations revealed that many surrendered specifically to avoid the terrifying fate of being eliminated by concentrated gunfire. This unprecedented break in discipline represented a complete breakdown of the strict warrior code. This code had sustained Japanese naval resistance through all previous battles. The fear of the gunships had overcome centuries of military tradition. Lessons learned from the first deployment were immediately applied and refined throughout the Pacific theater. This transformed not just how convoys were attacked, but which targets were prioritized during engagements. The gunship's strength lay in its ability to deliver overwhelming volumes of fire to specific hardened points on ships. This capability allowed for neutralization of escort vessels before vulnerable cargo ships could be targeted and sunk. The first major systematic employment of evolved tactics came during the assault on crucial supply depots 2 weeks later. Japanese forces had constructed a formidable screen of 10 escort vessels around 5 massive high-value targets. Oil tankers and ammunition transports represented critical strategic assets. Lieutenant Colonel Devlin commanded the bombardment squadron throughout this operation. He documented the new operational doctrine in official records. Conventional reduction of escort defenses carried an estimated 60% aircraft loss rate. Gunships would now execute preparatory suppression before torpedo planes advanced to engage primary targets. Marine Corps' records show the systematic reduction proceeded in a carefully planned grid pattern. Gunships operated in flights of 4 aircraft. They no longer focused on sinking escort vessels outright. Instead, they concentrated on permanently eliminating each ship's ability to fight back effectively. Target priorities included centralized fire control directors and bridge structures. Armor-piercing rounds bypassed light armor protection to destroy the nerve centers of enemy ships. In one documented action, the pilot of B-25 Valkyrie targeted the bridge of destroyer Asaduma. The concentrated burst of 8 guns destroyed the fire control position completely. It also took out the ship's primary radar mast and severed communication lines. The vessel was effectively blinded and rendered unable to coordinate defensive fire. Multiple defensive positions were found disabled or abandoned before low-level torpedo planes were even committed to their attack runs. The operation demonstrated the Japanese forces were choosing preservation of crew and hull integrity. They abandoned suicidal fights for their positions. This represented unprecedented behavior on such a large scale. Success prompted experimental modifications to be developed on the ground level. Airfield maintenance crews worked under intense pressure to develop new techniques. The splash and skip method modified gun sight depression angles. This allowed tracer streams to intentionally hit the water several meters from target vessels. Impacting rounds would skip off the surface into the sides of hulls. Often, these struck below the waterline, causing localized flooding. Simultaneously, they suppressed topside anti-aircraft positions. This dual-effect technique made gunships terrifyingly effective in multiple ways. It created no-win scenarios for targeted escort vessels. They faced both flooding and suppressed defensive fire simultaneously. Colonel Takamura commanded the Naval Air Fleet and studied American attack reports carefully. He attempted to counter gunships with aggressive deployment of long-range fighter patrols. However, the B-25's heavy forward armor proved highly effective against head-on fighter passes. Tail gunners provided defensive fire against pursuing aircraft. Low-altitude flight made interception difficult for Japanese fighters designed for high-altitude combat. The Iron 8 remained the undisputed champion of convoy attack missions. Its concentrated firepower negated even the most determined resistance from Japanese sailors. Operational success of the Iron 8 was only possible due to massive industrial support extending far beyond the aircraft itself. Sheer logistical demands of the modification program demonstrated American industrial capacity that Japanese forces simply could not match. Gunships required astronomical amounts of specialized ammunition for sustained operations. Armor-piercing incendiary rounds were manufactured in purpose-built chemical plants throughout the American heartland. Production required specific alloys and chemical compounds for incendiary cores. The Air Ordnance Battalion was specially created for this campaign. They documented staggering daily consumption of 50-caliber API ammunition at peak operational tempo. Navy construction battalions worked alongside specialized air depot teams. They built fuel storage facilities and rearming installations. Bespoke gun synchronization shops operated even during combat operations on hastily constructed forward airfields. By the campaign's peak, infrastructure included high-speed electric reload mechanisms for gun bases. Forward mixing stations produced specialized lubricants and cooling fluids. Miles of dedicated transport lanes carried heavy ammunition crates to forward positions. The entire supply chain stretched from stateside chemical plants producing incendiary compounds to forward maintenance sheds in combat zones. This highlighted a disparity in industrial output that was itself a strategic weapon. Japanese military assessments documented in post-war interrogations acknowledged harsh reality. The combination of gunships and relentless supply chains had negated their entire convoy defense strategy. Some Japanese naval leaders testified that this realization influenced later strategic retreat considerations. The impact was greater than the loss of specific aircraft carriers. Allied ability to produce and field weapons requiring such constant immense logistical support demonstrated resource depth. The Japanese Navy, relying on sporadic supply runs and artisanal maintenance, could not comprehend this capability. They certainly could not counter it effectively. The 8-gun nose was more than just a tactical innovation. It was the embodiment of assembly line production, defeating warrior spirit through sheer overwhelming force. General Kurosawa was in charge of naval logistics for the southern operational area. He transmitted a final message before his capture that acknowledged grim truth. The enemy's relentless ability to produce and fire such volumes of metal had overcome their fleet's courage. Japanese spirit could not stop streams of 8,000 rounds per minute. This message was intercepted by Allied radio intelligence and confirmed the decisive impact of industrial power on naval warfare. The defeat was not merely tactical in nature. It was fundamentally an industrial defeat that could not be overcome through courage or determination alone. Lessons from the gunship innovation were immediately codified and applied to all subsequent naval operations throughout the Pacific. They fundamentally altered the course of naval aviation development for decades to come. Official military histories trace a direct lineage from the B-25 gunship to modern close air support platforms. The fundamental principle of using high-velocity, high-volume fire to suppress and neutralize hardened point defenses remains relevant to current naval warfare doctrine. The Air Force's official history makes a definitive statement about this innovation's importance. The development of fixed-nose gunships was the single most significant American technical innovation in the naval air campaign. Against Japanese convoy defenses, these weapons proved decisive in neutralizing escort screens. Without gunships, conventional torpedo or dive bombing tactics would have cost hundreds of aircraft and thousands of irreplaceable airmen. Admiral Nimitz served as Commander-in-Chief Pacific Fleet throughout this period. His confidential report noted that fixed-nose gunships proved to be the most effective weapon for systematic reduction of naval flak defenses. Without these aircraft, losses of irreplaceable torpedo bomber crews would have been infinitely greater. The comparative analysis between old and new methods was stark and undeniable. Traditional convoy attacks required multiple waves of vulnerable aircraft flying into concentrated defensive fire. Expected losses ran between 40 to 60% per mission to achieve limited results. Gunship operations could neutralize multiple escort vessels per hour with minimal friendly casualties. The 8 gunships initially deployed to the Southwest Pacific saved countless airmen's lives while preserving valuable aircraft assets for future operations. Japanese perspective, documented through post-war testimony and captured documents, confirms total negation of their defensive strategy. Forces that had been prepared to die honorably in conventional combat found themselves helpless. They faced a form of attack that rendered their defense systems useless from safe distances. This technological defeat preceded and enabled the physical defeat of their vital supply lines. The psychological burden on B-25 gunship crews was unique among combat aircraft personnel. Veterans Administration studies conducted after the war found these crews experienced combat stress at significantly higher rates than conventional bomber crews. The intimate nature of low-level attacks created unprecedented psychological challenges. Visual and auditory awareness of immediate enemy casualties was unavoidable at such close range. While the weapon was universally hailed as a savior of Allied lives, crews who flew the Demon Zipper carried distinct and heavy moral weight. The intimate delivery of such overwhelming violence created unique psychological burdens that would affect these men for years after the war ended. The battle for Southwest Pacific convoy routes ended not with a massive decisive fleet action, but with systematic cessation of organized resistance. Escort screens simply could not maintain their defensive positions under concentrated gunship fire. The ability of these aircraft to engage and neutralize the enemy's most cherished defensive weapon at safe distances proved fundamental truths about industrial-age warfare. Japanese defenders had staked their entire strategy on the concept of area denial. Their carefully constructed flak dome was believed to be completely impenetrable. The Iron 8 proved that this defense was merely a matter of engineering and logistics that could be overcome. Streams of concentrated fire maintaining lethal density up to 1,000 yards did not just suppress anti-aircraft guns. They cleared away illusions that courage and determination could overcome overwhelming technological superiority. Japanese crew members who abandoned their gun positions when confronted by B-25 gunships made rational decisions. They faced technology that rendered their prepared positions into death traps. Their careful preparations based on traditional air attack expectations proved worthless. Pilots could eliminate them while remaining completely outside their effective defensive range. The gunships deployed throughout this campaign proved fundamental truths about modern warfare. Victory belongs not necessarily to the brave, but to those with superior tools and industrial capacity to employ them effectively. Japanese defenders discovered that naval spirit could not stop armor-piercing rounds. Determination meant nothing when thousands of rounds per minute were directed at precise positions from unreachable distances. Systematic destruction of vital supply convoys was completed by summer's end. Convoy losses crippled Japanese ability to reinforce their island garrisons throughout the Pacific. The failure was a testament to harsh realities of modern war. Industrial capacity multiplied by technological innovation equals victory regardless of human courage on the opposing side. The B-25 gunship stands as permanent testimony to the moment when concentrated air-to-surface fire transformed the nature of naval engagement. It demonstrated the decisive power of technological surprise in modern combat situations. The impact of gunships was perhaps most acutely felt not in cockpits, but in the highest echelons of Imperial Japanese Navy command structure. Admiral Nishimura had been the architect of the supposedly impregnable convoy defense system. He was forced to confront the weapon that rendered his entire strategy completely obsolete. His final message was transmitted before his flagship was sunk during a desperate final sortie. This provided the most damning evidence of the Iron Eight's decisive power throughout the campaign. The intercepted and decoded message read that enemy fixed-gun aircraft had neutralized their anti-aircraft screens completely. Positions requiring months to fortify were destroyed in mere seconds. American firepower velocity had overcome Japanese preparation and planning. They could not maintain defensive positions against such concentrated streams of fire. Post-war testimony from the few Japanese naval survivors confirmed deep senses of terror and hopelessness these weapons inspired throughout their ranks. One officer providing testimony to military historians stated that sailors who had faced certain death courageously in traditional naval battles fled from B-25 gunships. The weapon created a form of defeat that contradicted their fundamental concepts of honorable military service. Being systematically gunned down from safe distances before they could return effective fire violated every principle of warrior conduct. Lessons learned by Allied forces immediately influenced planning for Operation Cartwheel and subsequent offensive operations toward the Japanese mainland. Joint Chiefs of Staff documents indicate planners urgently requested production of thousands of specialized 50-caliber API rounds. They also demanded conversion of additional B-25 airframes into gunship configurations. The demonstration that concentrated high-volume fire could systematically neutralize naval flak defenses altered every subsequent invasion calculation and strategic planning session throughout the remainder of the Pacific War. The commanding officer of tactical air units, General Devlin, filed his detailed after-action assessment, describing this transformation as warfare fought across 3 dimensions simultaneously. Combat raged above the ocean surface while operating crucially beyond the enemy's defensive reach. These converted aircraft established the foundation for future low-altitude strike platforms. They proved specialized technology could defeat superior numbers. Traditional naval defense systems had been thoroughly exposed. The Navy's standard-inch artillery and conventional cannon positions proved woefully inadequate against the devastating power of American automatic weapons multiplied 8-fold. The sheer volume of coordinated fire overwhelmed every defensive measure the enemy possessed. Military leadership celebrated the B-25 conversion as vital for reducing Allied casualties. However, this revolutionary method of combat brought unprecedented moral and legal complexities. Military chaplains and legal officers documented these challenges extensively in their reports. The systematic elimination of anti-aircraft gun crews through overwhelming distant firepower was brutally effective. Yet the moral implications weighed heavily on many minds. The nature of this warfare troubled military chaplains significantly. They reported dramatically increased counseling requests from gunship crews compared to standard bomber units. The intimate nature of low-altitude attack runs created unique psychological pressures. Crews heard every sound of sustained gunfire echoing through their aircraft. They witnessed the visual confirmation of destruction with stark clarity. This combination generated intense combat stress among airmen. One military chaplain recorded in his personal diary the crew's internal struggle. Pilots understood the tactical necessity of their mission completely, yet they wrestled with the finality of unleashing 8,000 rounds per minute directly into human targets. These enemy gunners possessed no effective means of retaliation. Despite moral concerns expressed by some crews, military legal reviews reached clear conclusions. These assessments occurred during wartime operations and continued after the conflict ended. All reviews confirmed the complete legality of gunship operations under international law. No specific weapon prohibition existed within the Hague or Geneva Conventions regarding these aircraft modifications. Military vessels defending their positions represented legitimate targets under established laws of war. Post-war tribunals examining war crimes never prosecuted the deployment of fixed-gun aircraft. Military courts deemed these weapons proportional and necessary responses. The Japanese Navy had constructed heavily fortified anti-aircraft positions that conventional methods could not neutralize without unacceptable Allied losses. Extensive documentation fills the National Archives regarding these specialized operations. Detailed war diaries and comprehensive technical assessments preserve the complete record. These documents consistently emphasize the gunship's breakthrough importance in naval interdiction tactics. Combat photographers captured remarkable visual evidence, showing the characteristic flash and smoke patterns. 8 guns firing simultaneously created unmistakable signatures visible from great distances. This photographic record, now preserved in military archives, demonstrates the weapon's devastating effectiveness against naval fortifications. The deployment represented far more than tactical innovation alone. It demonstrated how industrial specialization and technological adaptation could fundamentally transform combat dynamics. These specialized weapons completely negated defensive advantages the Japanese Navy had spent years developing. Their entire strategy relied heavily on short-range, dense defensive fire. Concentrated streams of metal projected across vast distances accomplished more than silencing enemy guns. They completely obliterated established Japanese naval doctrine based on close-range defensive tactics. The legacy of these converted bombers extends beyond military records into post-war reconciliation efforts. Annual naval honor ceremonies and veteran reunions document remarkable healing between former enemies. These gatherings bring together former Japanese naval personnel and Allied aircrew members. Former adversaries discovered common ground through shared traumatic experiences. Anniversary reunions, held at sites relevant to major naval battles, created opportunities for mutual understanding. Japanese survivors openly acknowledged the technological superiority of American gunship modifications. American veterans expressed profound respect for Japanese gunners' courage. Despite complete futility, enemy crews attempted to maintain their defensive positions under impossible circumstances. Military historians and cultural organizations have documented these reconciliation meetings extensively. They provide crucial perspectives on the broader conflict's human dimensions. Japanese naval veterans acknowledged the weapon presented an impossible choice. They faced honorable but suicidal resistance or practical survival. The clear technological gap made fleeing or surrendering rational decisions. This reality overrode deep cultural imperatives, demanding fights to the last man. The few remaining veterans of specialized gunship units have provided final testimonies for historical preservation. These accounts consistently emphasize both the tactical necessity and horror of this form of warfare. One former gunship pilot, Captain Hayes, provided particularly stark testimony. He described their mission as a butcher's work that remained their essential duty. Every stream of concentrated fire they directed downward represented lives saved among their own forces. Those silenced anti-aircraft guns could no longer threaten Allied bombers or torpedo aircraft. The 8-gun nose configuration ultimately proved that the Pacific War was fundamentally a contest of industrial capacity. Japanese forces prepared extensively for battles, testing individual skill and fighting spirit. Instead, they encountered technology that completely negated both advantages. Their fierce determination became meaningless when armor-piercing incendiary rounds shredded their defenses. These rounds were produced by America's tireless industrial base from distances their weapons could never reach. The gunship's impact on naval warfare remains singular in military history. It represented decisive innovation that significantly shortened campaign duration. Thousands of Allied airmen survived because of this technological advantage. The weapon's very existence forced fundamental changes in Japanese naval doctrine. These doctrinal shifts ultimately reduced the overall scale of Pacific theater conflict. Concentrated fire streams crossing the Bismarck Sea demonstrated a crucial principle of modern warfare. Technological superiority represents more than mere advantage in contemporary conflict. It serves as the essential precondition for achieving victory against determined opposition. The story of the B-25's 8-gun nose provides a powerful reminder. The smallest technical modifications can shift entire global conflicts dramatically. Converting a glass bombardier position into a solid metal wall of death changed everything. Initial gunships deployed to Southwest Pacific campaigns proved fundamental military truths. Battles are won not through courage alone, but through superior adaptation. The Japanese Navy's fundamental flaw was not lacking courage or determination. Their failure lay in not recognizing and adapting to weapon systems that broke long-accepted rules of naval aviation warfare. Japanese forces prepared extensively for torpedo attacks and high-altitude bombing raids. They were ultimately defeated by a flying, oversized machine gun platform. Their commitment to anti-aircraft gun positions, excellent at close range, became a strategic liability. The moment Allied forces found methods to deliver overwhelming firepower outside protective gun ranges, entire defensive systems became self-contained death traps. The concentrated firepower of the Iron 8 perfectly countered the concentrated flak of Japanese defensive domes. Final accounting numbers speak for themselves with stark clarity. Systematic convoy destruction deprived Japanese forces of essential supply lines. This directly enabled subsequent Allied land campaign successes across the Pacific theater. Allied costs remained minimal throughout these operations. Japanese losses proved catastrophic in multiple dimensions. They lost precious supplies, irreplaceable ships, and most importantly, psychological will to continue defending convoy routes. Today, preserved B-25 airframes stand prominently in military museums worldwide. Sometimes the intimidating gun nose is proudly displayed for visitors to examine. These aircraft serve as monuments to more than successful military engineering. They represent monuments to the strategic power of single ideas born from desperation. Relentless industrial capacity fueled these concepts into battlefield reality. They remind modern observers that military history is often written not by grand fleet battles. Instead, engineers and airmen who found methods to bypass enemy strengths entirely wrote crucial chapters. The B-25's 8-gun nose represents lessons still relevant in contemporary warfare. The most feared weapon remains the one enemies didn't know they needed to defend against. The gunship story, known as the Iron 8, offers timeless lessons in strategic asymmetry. Japanese naval forces, through meticulous preparation, focused all available resources on creating extremely effective short-range defenses. Their success in converting convoy vessels into floating fortresses was undeniably impressive. However, this focus created a critical strategic vulnerability. They built brittle defenses that failed completely once technology bypassed the outer protective layer. This principle echoes throughout military history and extends beyond warfare itself. Examples range from heavily fortified positions being circumvented by mobile armored divisions to modern cyber defenses being exploited by zero-day attacks. The crucial lesson involves more than ammunition caliber specifications. It concerns inflection points, where one side stops fighting enemy strengths and starts exploiting self-imposed weaknesses. Pilots flying these gunships weren't merely attacking individual ships or convoys. They were systematically attacking the foundation of Japanese naval doctrine itself. By destroying fire control centers and silencing guns from hundreds of yards away, they accomplished more than saving their own lives. They proved that enemy forces had strategically misallocated their defensive resources throughout the theater. This realization that their best efforts had become meaningless served as the true psychological weapon Japanese commanders feared most. Today, military planners still reference these operations as textbook examples of weaponized doctrine negation. The difference between defeating enemies in fair fights and changing fight rules entirely becomes clear. Japanese forces prepared for traditional naval boxing matches. Allied forces appeared with long-range rifle capabilities instead. The ultimate tragedy for Japanese naval command was their constant adaptation to yesterday's battles. They learned to defeat previous torpedo bomber tactics effectively. Yet they were blindsided by aerial gun platforms representing future warfare capabilities. The B-25, originally designed as a standard medium bomber, transformed into an entirely new weapon class. It became the first true aerial anti-defense platform in military history. Its enduring legacy serves as stark reminder that in any major conflict, the side adapting fastest with industrial capacity to mass-produce adaptations will ultimately prevail. The cost of several B-25 conversions resulted in collapse of an entire regional supply strategy. That represents the fundamental arithmetic of modern warfare. Now that you understand the complete story of the Iron 8, the weapon that broke Japan's best naval defenses, engagement with viewers becomes important. The technological leap from standard bomber to specialized gunship was truly monumental. It required ingenuity, desperation, and unbelievable industrial manufacturing capacity. The critical question for consideration involves identifying the single biggest factor in gunship success. Was success primarily due to sheer volume of fire, measured in rounds per minute? Was it the specialized armor-piercing incendiary ammunition that transformed metal into fire? Or was it the strategic decision to operate outside enemy maximum effective range consistently? Viewer engagement through comments provides valuable feedback and discussion opportunities. Every comment receives attention, and outstanding answers receive highlighting in subsequent videos. Support through likes indicates algorithm preference for detailed military history content. Subscription and notification activation fuel the research and script writing process. These detailed, historically accurate narratives require thousands of hours of research and careful script writing. Viewer support provides essential fuel-maintaining content production capacity. Platform dedication focuses on delivering comprehensive military history content of highest quality. Audience support remains absolutely vital for continued operations. Previous exploration revealed how single technological shifts redefined air-sea battle dynamics. Innovation continued progressing throughout the war as Allied forces developed increasingly sophisticated weapons. These weapons were designed not merely to destroy targets, but to manipulate battlefield conditions. Some turned enemy environments against opposing forces directly. The next story involves weapons so secretive and terrifying that testing procedures nearly destroyed entire projects. It examines weapons developed for final Pacific War phases that required absolute secrecy. Strategic shockwaves from gunship operations forced Imperial Japanese Navy leadership into desperate countermeasures. Admiral Nishimura's successors, tasked with maintaining critical supply lines, quickly realized problems extended beyond individual ships. The predictable nature of defensive arrangements created systemic vulnerabilities throughout their operations. Primary adaptation involved introducing floating flak barges, officially designated Type 10 auxiliary escort platforms. These were not traditional warships, but heavily modified slow-moving barges and shallow draft vessels. They were positioned outside convoy perimeters, sometimes hundreds of yards away from main formations. Their sole purpose involved acting as distractions while extending overall anti-aircraft coverage nets. They carried surplus weapons and heavier guns with slightly longer ranges than standard installations. The strategy aimed to draw B-25 gunships into engaging heavily armed but low-value targets. This would force Allied aircraft to expend limited armor-piercing incendiary ammunition before reaching main convoy vessels. Secondary tactics implemented night flak blindness procedures, utilizing newly developed short-range search radars and powerful parabolic searchlights. Convoys began moving exclusively under darkness, hoping visual confirmation loss would negate extreme precision required by B-25 pilots. Accurate hits on tight, vulnerable gun positions demanded clear visual targeting. While B-25s could locate convoys using radar systems, low-level high-speed attack runs in total darkness significantly increased risks. Pilots faced greater chances of ditching aircraft or missing target structures entirely. However, Allied responses to these adaptive tactics proved swift and decisive, demonstrating ultimate industrial and intellectual advantages. B-25 airframes received rapid modifications with specialized low-light amplification sights, early versions of night vision technology. These provided pilots sufficient visual contrast to maintain accurate aim during darkness operations. Furthermore, gun noses served purposes beyond direct fire engagement. Pilots developed thunder run tactics, flying directly toward flak barges at maximum speed while firing short, concentrated bursts. This often panicked less experienced crews manning the barges, causing them to cease fire or abandon positions before main B-25 forces arrived. The introduction of floating flak barges, while extending defensive ranges, created new vulnerabilities. Larger guns required heavier and more volatile ammunition supplies. When hit by armor-piercing incendiary rounds, resulting secondary explosions proved catastrophic. Barges often sank instantly, while creating massive fireballs that served as giant, irresistible beacons for follow-up attack waves. Imperial Japanese Navy attempts to counter gunship operations only confirmed B-25 fundamental superiority. Japanese forces poured precious resources into defensive platforms that merely offered larger, more explosive targets. American technology and industrial capacity consistently stayed multiple steps ahead of countermeasures. Gunship success represented as much a triumph of pilot training as technological innovation. Flying medium bombers at wave-top level, often below 50 feet altitude, at maximum speed, directly into oncoming walls of flak, demanded entirely new skill levels. These missions required exceptional nerves under extreme pressure. The B-25 proved notoriously difficult to handle at these low altitudes, especially when fully loaded and trimmed heavily forward by gun assemblies. The Specialized Air Training Group for Special Operations was established specifically to train gunship crews. Training programs were brutal and completely unforgiving. Pilots mastered techniques known as flat spin recovery, necessary skills when aircraft tails clipped waves during high-speed maneuvering. They practiced repeatedly over dummy targets in restricted bombing ranges, learning to hold aircraft steady during full 8-second bursts. Simultaneous discharge of thousands of rounds per minute created tremendous backward recoil and torque. This could violently pitch noses up or yaw aircraft off course if pilots weren't perfectly braced and coordinated. Crucially, crews received training in target zoning methodologies. They learned to visualize escort vessels not as ships, but as series of 10-foot by 10-foot zones. All firepower was directed at zones containing primary anti-aircraft guns and fire control systems. Goals involved achieving complete neutralization of enemy fighting ability, not necessarily sinking ships entirely. This surgical approach minimized expenditure of precious armor-piercing incendiary ammunition while maximizing psychological impact. Average crew members were younger and often more aggressive than standard bomber crews, reflecting high-risk mission nature. They were selected for exceptional nerve and precision under extreme pressure. Unit Commander Colonel Devlin fostered unique culture within the squadron, combining high professionalism with almost arrogant confidence. They referred to missions not as bombing runs but as disarmament exercises. Psychological stress was immense, yet morale remained high because mission objectives were crystal clear. They directly saved lives of comrades in torpedo and dive bomber squadrons who no longer faced lethal flak domes. Airmen knew their missions were not merely destructive, but actively preventative. This sense of being flak breakers created deep bonds within squadron units. Post-war analysis revealed that while units suffered high stress levels, mission success rates and survival rates relative to damage inflicted exceeded other low-level attack aircraft exponentially. They represented perfect marriage of human skill and technological force multiplication. B-25 conversion impact extended far beyond Pacific theater operations, permanently altering relationships between airframe design and mission specialization. Success proved that transforming existing airframes for highly specialized concentrated firepower roles was faster and more effective than developing new aircraft from scratch. This principle became foundation for several post-war airframe modification programs. First, success accelerated development of anti-armor weaponry in fixed-wing aircraft. Using high-volume, high-velocity rounds to defeat lightly armored targets led directly to design philosophies behind Korean War-era close air support aircraft. This culminated in adoption of large-caliber cannons as standard anti-ship and anti-vehicle weapons. The concept of aerial fortress noses became models for future gunship designs, prioritizing dense frontal shotgun patterns over precision bomb placement accuracy. Second, extreme logistical demands of armor-piercing incendiary ammunition supply chains forced United States industrial military complex to fundamentally rethink forward ordnance support. High consumption rates necessitated creating dedicated containerized reloading units that could be quickly deployed to austere forward operating bases. This innovation in logistics, matching supply chain speed to weapon consumption rates, represents direct uncredited legacy of gunship programs. The ability to supply thousands of rounds daily to remote Pacific islands proved American industrial power could overcome any geographical obstacle. Third, Japanese were not the only forces taking detailed notes. German and Soviet intelligence, reviewing captured data after war conclusion, were profoundly influenced by B-25 gunship performance records. Soviets, particularly, adopted ideas of large-caliber fixed-forward guns on ground-attack aircraft. They recognized efficiency of focused firepower against hardened ground and sea targets. Gunship success served as economic and political testament to effectiveness of strategic industrial spending. Cost of entire programs, including aircraft, conversions, and millions of ammunition rounds, was dwarfed by costs of losing single major fleet carriers. High casualty rates associated with continued conventional convoy attacks made gunship programs economically efficient. The 8-gun nose was powerful argument for efficiency of strategic technological investment. It proved sometimes the most cost-effective weapon forces enemies to stop fighting altogether. The deepest fear Japanese Navy harbored regarding B-25 8-gun noses was not visible fire or tangible destruction. They feared invisible technology they couldn't see and couldn't counter effectively. Japanese military machines were built on principles of fighting spirit, believing superior determination and courage could overcome technological deficits. Gunships, however, were designed to defeat fighting spirit itself. They removed opportunities for heroic combat entirely. Concentrated distant fire created forms of death that were impersonal, inescapable, and rapid. Gun crews had no time to comprehend threats fully, much less fight back effectively. Gunships broke implicit contracts of close-quarters naval combat. In essence, they were ultimate applications of concentration of force principles. By stripping bombers of payloads and dedicating all structural resources to 8 synchronized guns, Allies achieved unparalleled firepower density on single fixed points. No existing Japanese naval platform was designed to withstand that kind of surgical concentrated volume. B-25 legacy is defined by this psychological victory. Pilots demonstrated that technological ability to dictate engagement terms was more valuable than any other military asset. They forced naval warfare to be fought at ranges where Japanese guns could not reach, thereby turning naval defenses into greatest liabilities. Admiral Nishimura's entire defensive strategy was predicated on drawing enemies close. The Iron 8 proved American ingenuity had found ways to win without accepting that invitation. Gunships were, in final analysis, embodiment of American industrial and intellectual dominance. They represented fusion of aerodynamic platforms, specialized ordnance, and precise intelligence, resulting in single weapon systems that achieved complete strategic victory over entire military doctrines. Today, military strategists look back at B-25 conversions and recognize them as pivotal weapons, demonstrating devastating power of adapting existing technology. They created specialized, surgical, and technologically superior countermeasures that remain relevant today. They remain the reason why, to the last Japanese naval crewmen who faced them, 8-gun noses were the most feared weapons in the Pacific theater.